Hello everybody. I'm back at my countertop with some goodies here that you might recognize, or maybe you've even thought about what we're going to be doing because you recognize some of these things. I have simply cut out some things out of cardboard that had some seltzer waters in it. And it's a thin cardboard, but you could use a thicker cardboard or just find something around the house. This is about balance and motion. So we know that things can move. That's the motion part. And we know that things can balance. A stable balance is when something is balanced and it is very stable. It's not going to fall over with a gentle sort of blow. We know that if a gale came, it would fall over, or if the vacuum cleaner blew on it. But you might recognize some of these shapes, the arch, the square, the triangle. I've got a couple of new ones here. So what you need is some cardboard shapes and some counterweights. Our clothespins were our counterweights at school, and they're going to be our counterweights for this project too. This is a chance for you to amaze your family. So we know that I could probably balance this on my finger. But it's not really a stable balance because if I blow on it, it simply falls off. This is going to be a stable balance. Shake your heads, yes or no. You know, not going to happen. Not going to happen. Not going to happen. Not going to happen. So we've got to use our engineering brain, our scientist brain, and figure out, okay, we know that if we use a counterweight, if we put a weight somewhere, that we can get these things to balance. And counterweights need to come below the balancing point. So if I want this to be a stable balance, I'm not going to put anything up above where I want it to balance. I'm going to put them down as low as I can. So I'm going to put a counterweight here and a counterweight here. Let's see what happens. I can move my hand all around, and that is a very stable balance. Very stable. And you might think, well, that one was pretty easy, Miss Allen, but let me show you. If we look at the other end, we go like this. This one's not going to be so easy. I don't have anything below to put my counterweights on. So, I've got to think about this. I know they have to go below where my finger touches. So I'm going to come, maybe I'll start here. Let's see what happens. Okay, they go below my finger. Oh, but that did not work. But I can see a little bit of, so I'm going to see if I can make it even lower. I'll bring my clothespin down a little bit more to where my finger is and see what happens then. Oh, look at that. That is a stable balance. I can walk around the house with that. Amaze my friends. Just using the same shape. What might be something else we could do? Maybe we would like to try to balance on this end. So I'm going to hold it here. Well, let me show you the plain side. Here, I've got to go as low as I can go with those counterweights. So I'm going to start way down here. Let's see if that does it. Oh, that does a pretty good job. Let's see if two of them improves it. I don't know. Okay. That's a pretty good balance. I can move my hand. I could walk through the house with that. Could walk with my house through my house. I could, I can't really hang it there, but you could find, if you put a string up, you could hang something on a string in your house. Okay, so that was the arch. So let's see. We've got a triangle. So if I wanted to do it here, I've got to go as low as I go. There's nothing below here. So we're going to go as close to the balancing point as possible and see if that does it. Oh, look at that. It just took two counterweights. The cardboard is really quite light, so it didn't take much. Let's see what happens if we want to go to the point. Remember, our weights have to be below where we balance. That's pretty hard to do because there's nothing down here to clip to. So we have to make that lower by coming close to the balancing point. We don't want to cheat and make it so tight that our fingers are caught by the pins, because that doesn't work. That's just cheating, and we don't need to cheat because we're smart. So we're going to pull these down as far as we can and see what happens. Oh, that's pretty good, but I think I can make it more stable by adding an extra weight to my counterweight. So I'm going to go here and here. Look at that. I could just walk around. You could make these into funny characters and walk around with them. They could be in a play. You could draw a picture and have them come up and they're talking and wiggling. Could do all kinds of things, or just make them beautiful. Let's see. Taking my counterweights off. Ah, this one similar to this one, right? Similar to the arch. Has an arch shape. I think it looks like a bird. If you put a bird's head up here and down here, let's see. If these are the wings of our bird, we don't have a head, but could make a head. Let's see, is that going to do it? Well, that's pretty good. It's balancing. I could walk around with that. That might be as good as it gets. If we make it a bird head, it would actually, sort of look like it was flying. I'll try another counterweight and see if that helps. It might be too much for this, but let's see. It's a little too much, but it's still there and it is still balancing. Okay, so you've got, this is just an odd shape. You could do a star, you could do you got a big square, could do it here, could do it here. Then we have this. We didn't do anything really too many three-dimensional things when we did it, but here's our toilet paper core. And I'm just looking at this and thinking, so I can probably, kind of try to balance it on my finger. It's not going to be very stable. I might be able to hold it up for a few seconds, but not very long. We need to make that a stable balance. So I want to balance it right here. So I'm going to put my weight here and my weight here because my finger's going to go right there. All right, that's not good enough to me. Let's add a little bit of extra weight because it's counterweight. Ah, look at that. Look at that. So this is the idea when you go to the circus and you see somebody on the high wire and they're walking across it and they have that long stick and that stick droops down and there are heavy weights at the end of that stick and they help the walker to be very stable on that wire, just like this would be stable if we set it up there. So that's the idea that you might recognize is going to the circus and seeing somebody walk on the high wire. You could make circles or any kind of shape that you wanted, and you could experiment with that. You could go crazy and find something that's like impossible to do and see if you can do it. And then I have one last thing that I'm going to show you. All right, so this was our pencil trick. Now, I'm trying to do this trick with things that I sent home with you because this is you had pipe cleaners that I sent home with you. And I tried to wrap them around, so I just had one, but these were just not strong enough. So I did wrap it in the middle. I connected four of these and wrapped them around. I had to use a little bit of tape to make it because it wouldn't slide off the pencil. And then look at that. I got my pencil to just rest on the tip of my finger, just like that. So going back to the lessons that we did in class, remember it's trial and error. Try it, change it, try it, change it until you get it to do what you want it to do. If it's possible, you can do it. All right, friends, this was Balance in Motion. It involves a stable balance on a balancing point, which is your finger most of the time, and it is helped by counterweights, which are our clothespins today. All right, friends, have fun balancing. Bye.